going to be working through the 9.7 and 10.1 homework again, just to give y'all better clarification. I am going to do the 9.7 first, and then I'll do 10.1. So I'll send you two separate videos. The first problem in 9.7 was talking about in 2012, the population of a city was 6.04 million. The exponential growth rate was 3.85% per year. So the growth function is P of t equals P0e to the kt. So here's the two things that I feel like I'm going to better explain now than I did earlier this week. P of t is always where you end up. No matter what you're talking about, that's it's where you're going to end up. The P little 0 is where you start. The K is still the rate, and the T is time. So the first part of this one says the exponential growth function is blank, where t is in terms of the number of years since 2012, and P of t is the population in millions. So let's see what we do know. It tells me that 6.04 million is where we started, right? That's the starting population. We do not know where we end up. That's what we're looking for. We do know the rate. It tells us the rate is 3.85%. Now, when you do the rate, it's always in decimal form, which means I need to change this percentage to a decimal or move it 2 places to the left. So we're going to enter it as 0.0385. Now, from this information, I can come up with the growth function. P of t equals, so this P0 is where we started. Do I know where I started? Yes, the population started at 6.04 million. After that comes the E. I do know the K because I do know the rate. It's to the 0.0385, and then T for time because I do not know the time. So that's going to be the growth function that we're going to use to solve the rest of the problems. So that's the answer to the A part of the question. The B part says the population of the city in 2018 is how many million? So in 2018 is what we're looking at. Well, if we started in 2012, how long has it been? So this gives me that it's been 6 years. So that's what you're putting in for the time. So now I know where I started, the rate, and the time. So I can plug all that information in and then just use my calculator to do the math. So I am finding P of 6 years because that's what the T is now. So I've just replaced this T with the 6. So now equals 6.04 E to the 0.0385. Now I do know what T is, so that's where I put the 6. Now I just plug this in my calculator and do the math. So I'm just plugging this formula into my calculator. So 6.04 second E, and then up in the exponent I do 0.0385 times 6, close, and then hit enter. So and it tells me to round it to the nearest decimal place, which would be 7.6. So I have found that in 2018, the population will have grown from 6.04 million to 7.6 million. All right, the C part of the problem says the population of the city will be 9 million in about blank years after 2012. So this time, I do know where I end up, right? So this is going to be the first part of the equation. I do know that I'm going to end up at 9 million. I do know I started at 6.04 million. E. I do know the rate still, 0.0385. This time, I do not know the t. That is what I am solving for, is this t. So anytime you're solving for a variable that is in an exponent, that is telling you that at some point, I'm going to have to log, or in this case, ln, since it's an e, both sides, because that is what is going to bring the exponent down in front of the e. But before we do that, let's get rid of this 6.04 by dividing by 6.04. So that'll cancel that. So now I just have e to the 0.0385t equals 9 over 6.04. I'm not even going to do this math. I'm going to do the math on the left-hand side at the very end. After I get everything over there with it, I'll just punch it all in at one time. So now that I don't have anything in front of the e, I'm going to ln both sides. So I have ln, all I did was add an ln of e to the 0.0385t. If I ln this side, I have to ln over here. So now I have ln of 9 over 6.04. Now, the reason I ln'd is because the property of logs says if you have a log that has an exponent, you can bring that exponent down in front of the log and make it a product or times that log. So if I do that, I have 0.0385t of ln e. So we use that property. That's the whole point of this log right here, is to bring down the exponent in front. So now you'll notice the t is here, not up in the exponent anymore. I haven't done anything over here, so it's still ln of 9 over 6.04. Now, if you will recall, anytime you have log base something to that same thing, this right here in log base e is the same thing as ln. So this really says log base e of e. Anytime you have this situation, it is equal to 1, which means this right here is really just 1. So you can think of it as not even being there. So all I have left over here is the 0.0385t, 85t equals ln of 9 over 6.04. So to get t by itself, which is my whole goal, is to, so all I need to do now is to divide by 0.0385 on both sides. So over here, that'll cancel. I'll just have my t. Over here, divide this by 0.0385. So this is the math I can do all at once in my calculator. I just need to type in ln of 9 over 6.04 as my numerator and then divide it by 0.0385. Once I do that math, I will know what the t is. So again, just punching this. So ln, open parentheses, 9 over 6.04. Close it, because you want to just represent this as your numerator and then divide it by the 0.0385 and enter. So this right here, 10.35, we'll just call it 356. In the C part, it wants me to round to 1 decimal place, so it wants me to stop right here. So I'll look after the 3, since it's a 5. I will round that up to t equals 10.4. Now, the last part of the first problem is the doubling time is about blank years. So if you will recall, doubling time, the formula for it is ln of 2 over whatever the rate is, and we know the rate is 0.0385, so the doubling time is going to come from t equals ln of 2 over 0.0385, and then just do that in the calculator. ln 2, close, divided by 0.0385 gives me the doubling time rounded to 1 decimal place. So if you'll look at this, rounded to 1, it'll just still be 18.0, which is telling me that at a rate of 3.85%, it will take 18 years for the population to double. All right, problem number 2. Complete the following table. It gives me country A and country B, and then it tells me country A's growth rate is 2.6% per year. And then I'm looking for the doubling time. So again, it's that same formula. Doubling times formula is t equals ln of 2 over the rate. So since the rate is 2.6, I'll just do ln of 2 over, move this decimal place 2 places to the left, so it'll be 0.026. So again, ln, 2, close, divided by 0.026 gives me, rounding to the nearest whole number, which is going to be, since it's 26.6, I will round that to 27. So the doubling time is about 27 years. Okay, the next one tells me in country B, the doubling time is 33 years. So if you solved this equation for K, which is what we're looking for, is the rate, you would end up with K equals ln of 2 over the T, which means this time I do know the T. It told me the doubling time was 33. So I just put the 33 in place of this T. So K equals ln of 2 over 33, and then do the math. ln of 2, close, divided by 33 gives me 0.021, and I'm rounding it to the nearest tenth. So, but first I need to think 0.02100. To turn it to a percent, I need to move it 2 places to the right. So I'm left with 2.1% as the growth rate. All right, number 3. Suppose that $15,986 is invested at an interest rate of 5.7% per year, compounded continuously. So remember, P of T is where we end up. P0 is where we start. K is rate. T is time. So let's see, what do we know? It tells us that we invested $15,986. If we did that, that's where we started. We started at $15,986. So I do not know P of T. I don't know where we're going to end up. That's what we're trying to find. So if I know where we started, that's where the P0 goes. So 15,986. E, it does tell me the rate is 5.7%. So once again, move it 2 places to the left to get 0.057. So that'll go in place of the K. And I do not know T. So that's what we're solving for. So here is the growth function for this problem. So that goes in the A part of your answer. P of T equals, here's what you will enter. The next thing it wants to know for the first part of the second part of the question, the balance after 1 year. So I do know the time now. So if I know time, I can replace the t. So if I replace the t, I'll have p of 1. So I have 15,986 of e to the 0.057 times 1. And then just punch this in your calculator. So 15,986, second e. So for the up in the exponent, I'm going to do 0.057 times 1, close, enter. So after 1 year, rounded to 2 decimal places, so stopping right, whoops, y'all can't see that, right here, I'm going to stop it at that 67. So I'm going to have $16,923.67. Now, if you'll look, the next 2 parts of the problem, we just found this 1 year. For 2 years, you'll just replace the t with 2, which in other words, this right here will just be a 2. The 5 years, you'll just replace that t, which goes here, with a 5. And the 10 years, you'll just replace it with 10 to get those 4 answers. Okay? The last part, this C part, is the doubling time for this problem. So remember, doubling time is t equals ln of 2 over k. So all I need to know is the rate, which was that 0.057. So I just plug it in. ln of 2 over 0.057 and do the math. ln of 2 over 0.057 gives you, rounded to 1 decimal place. So this, since I'm stopping it here, I need to use this 6 to round that up to a 2. So it'll be 12.2 years for the money to double. All right, number 4. Now, number 4 is when we got into the exponential decay. So the formula for that is very similar to the exponential growth function. It's just going to be m of t is m0 e to the negative, whatever the k is, times t. So everything is represented by the same things. This m of t is still, that's always where we end up. M0, again, is where we start. Once again, K is rate and T is time. So again, these two things, this right here is going to be where we end up. This right here is where we start. So it says to use the data, or let me tell you this, the data in the table shows that the percentage of adults in a country who are currently married is declining, assuming that the percentage of adults who are married will continue to decrease according to the exponential decay model. Complete parts A through C. So the first thing it says is it gives us this chart. All that really matters in this chart is that it starts in 1960 where 74.7% are married. And then the chart stops at 2012, where only 42.3% of the population is married. So, what do I know? I know where we started. I know even where we ended up. And I know the time it took me to get there. So let's plug in what we know. Do I know where we end up? Where did the population end up? Well, it ended up at 42.3%. So now, on the other side, what's next in the formula? That m sub 0, which means where did we start? Well, where was the starting percent? It's at 74.7. Then the E, the negative. Here's what I don't know. I do not know the K, which is what the first problem is asking me. But do I know, so I don't know K, do I know the time? Well, looking at this chart, from the beginning to the end, it took me 52 years separate these two, right? From 1960 to 2012, which means I do know the time is 52. Now, since I'm solving for K, now remember, anytime you're solving for a variable that's in the exponent, at some point you are going to ln both sides because that's what brings things out of the exponent so you can solve for them. Before I do that, I'm going to divide both sides by 74.7. So e to the negative k times 52. Again, I'm not going to do this math over here until I have moved everything I can over here. So I'm just going to leave this as 42.3 over 74.7. Now is the time to bring this out of the exponent. So that's when I will ln both sides. So over here, instead of writing k times 52, I'm just going to write 52k. I'm just going to go ahead and multiply them together. If I ln this side, I have to ln this side. So now, this stays at ln of 42.3 over 74.7. The whole point of doing this was to bring that out of the exponent. So now I have negative 52k ln e, and remember what ln e is equal to. It's just equal to 1. So this over here is just a 1. So it kind of just disappears. So all I have left is the negative 52k equals ln of 42.3 over 74.7. Which means to get k by itself, which is what I'm looking for, the rate, I just need to divide both sides by that negative 52. You can do that all at once. I'm punching all of this right here in my calculator. So I have ln 42.3 over 74.7, close, and then divide that by negative 52. Which means, and it wants my rate in 4 decimal places. So 1, 2, 3, 4. So I'm stopping here. So I'm going to use it as 0.0109. So that's the first part of the answer. You have found K as 0.0109. Now, the next part, B, says to estimate the percent of adults who are married in 2015 and 2018. So we need to think. It started in 1960, ended in 2012, so that was 52 years. If we're going to go to 2015, that's only 3 more years. So that's 55 years. That's the time. That's the number I'm putting in the T spot. So remember, now that I know K is 0.0109, that's what I found in the first part. I know T is 55. I know where we started, so I know M0 was where we started was 74.7. So I'm looking for M of T when T is 55 to see where I end up. So let's see. I am finding M of 55. So what is the percent of people married 55 years after 1960? So let's plug this in. So where did I start? M0, so 74.7. E, I do know the rate, and I need to make it negative, right? That negative is what's going to make it decline instead of grow. So negative 0.0109, and I'm plugging 55 in for T. Okay, so here's what I just need to do this math. There's no variable up in the exponent or anything. I'm just doing this math. So just 74.7 E, so second E, then to the negative 0.0109 times 55, rounded to 1 decimal place as needed. So I'm stopping at 1 decimal place, so it's just going to be 41.0. Okay, the next part of that problem, I'm not going to work it out. It just wants to know what it is in 2018, which just is 3 years more. So work this same exact problem. Instead of finding M of 55, you'll find M of 58. Since 2018 is 58 years after 1960. So same thing, just plug in 58 instead of 55. Now, number 5. The number of farms in a certain state has declined continually since 1950. So it starts in 1950 with the number of farms being 82,145. And in 1995, so that's the ending point, that number had decreased to 24,394. Assuming that the number of farms decreased according to the exponential model, find the value of K. So I'm looking for the rate. Now remember, do I know where I ended up? Where did the number of farms end up? Right here. That's on the left side of the equation. So I just put the 24,394 there. Do I know the number of farms that we started with? Yes, that's the 82,145. And there's the E. I do not know the rate. That's what I'm looking for. I am looking for K. Do I know the T, the time? Well, all you have to do is look where you started, 1950, where you ended up, 1995, and say, how many years did it take me to do that? Well, it took 45 years. That's 45-year span, so your T is 45. So I'm solving for the K. So once again, I'm solving for a variable that's in my exponent. So at some point, I am going to have to ln both sides to move this out of the exponent. But before that needs to happen, I need to get rid of this 82,145. So I'll divide by it. So now I have E to the 45K equals, remember, once again, you don't ever do any of this math over on the left until you've moved everything over there. And then just do it all at once. So now all I have left is E to the 45K. So now it's time to bring that 45K out, which means I need to ln both sides. So on the left, I'll have ln 24,394 over 82,145 equals this. Now, since that's an ln, I can bring the 45K out of the exponent. So I just have 45K ln E. Once again, the ln E turns to 1. So all I'm left with over here is the 45K, which means I can finish up by dividing by that 45. So once I divide over here, once I punch in this math into my calculator, I will have solved for K. So again, ln 24,394, divided by 82,145, now close, and then divide that. Oh, what did I forget? This all needs to be negative so that I don't have to go back and restart the whole thing. Just make all this negative because we're decaying. We are not growing, which means that 45 just needs to be negative all the way down. So when I divide here, I'm dividing by negative 45. So I get 0.02698. So it's looking for the K. So it's going to be, it looks like all the answers are rounding it to the third decimal. So I'm stopping right here after the 6, which means this 9 will round this 6 up to a 7. So 0.027, which would tell you that it is the B answer. All right, last one for 9.7. Talking about decaying again. The reason I know that is because the problem says there are currently 71 million cars in a certain country. So I'm starting at 71, decreasing by 0.09% annually. How many years will it take for this country to have 63 million cars? So here's where I started. There's the rate. And it even tells me where I end up. So I started at 71 million cars, ended at 63 million cars. I do know the rate, that it was declining at 0.09%. Oh, that decimal's in the wrong spot. 0.9%. Okay, so I do know these three things, and I'm looking, what I do not know is what the time is. How long did it take to go from 71 million to 63 million at a 0.9 declining rate? So let's see. Over here, what goes over here? Where you end up is what you start with here. So I ended up at 63 million. I started at 71 million. E to the, here I'm going to remember it this time, negative. I do know the rate. Now remember, if I'm 0.9, I need to move this 2 places to the left. So the rate is negative, then put 0.009 t. That's what I don't know. I do not know the t. So let's solve for t. So again, divide by 71. So now I have e to the negative 0.009 t equals 63 over 71. ln both sides. That's what's going to get the t out of the exponent. So now I have ln of e to the negative 0.009 t equals ln of 63 over 71. So once again, that's what brings that out of the exponent. So now I have negative 0.009 t ln e, again, ln e turns to 1, equals ln of 63 over 71. So to get t by itself, I just need to divide by that negative 0.009 on both sides. That'll give me the t, which will tell me the time it took to go from 71 million to 63 million at this rate. So in the calculator, ln 63 over 71 close divided by negative 0.009 gives me, and it looks like round to the nearest year, so since it's 13.2, it will be 13 years.